In example 3.1, we saw this idea of a limit, and quite specifically we discovered that a limit will only exist if the function approaches the same value when x approaches from either above or below the x value of interest. If that's not the case, then the function doesn't exist. So the limit will not exist unless the function tends to the same value regardless of the direction of approach. So if we have a look at this graph here and consider the limit as x approaches 0. If we approach 0 from below, so here we are, we'll start at -5 and the value of the function is -1 and a bit. -3, the value of the function is approximately -2. -1, the value of the function is -6. -0.1, the value of the function is some very large negative number. Okay. If we have a look at, so we'll say the limit as x approaches 0 from below of f of x is a large negative number. That'll do for the moment. Okay. If we do the same thing approaching 0 from above, looking at the value of x is 5, the function is 1 and a bit. When x is 3, the function has a value of 2. When x is 1, the function has a value of 6. When x is 0.1, for example, the value of the function is some very large positive number. So we've got this situation now where we've got the limit as, two i's. Limit as x approaches 0 from above is some large positive number. Now, because these two are not the same, the limit doesn't exist. So for a limit to exist, the value of the function must be the same regardless of whether you approach from negative or positive, from above or below. In this case, the limit doesn't exist. You could say that the limit, you could either just state that the limit doesn't exist or the limit is undefined. And that's it.